I'm going to explain about relation between VDS and IDS, voltage between drain and source, and the current between drain and source. So in a MOSFET, so how the current relation with voltage, that is explained as, that is the current between drain and source can be defined as, that is electron transit time, or else the induced charge at the channel QC by, that is electron transit time, that is tau. So this is the relation, but we need to expand this. I will explain clearly. So induced charge at the channel tau, and this is the induced charge, and this is the electron. How much time it will take from electron is moving from here to here. So I will explain clearly. So that is IDS can be defined as induced charge at the channel QC by electron transit time tau. So but the induced charge electron transit time can be defined as, that is length by velocity, length by velocity. But length by velocity, velocity can be defined as, that is mobility of the electron into electric field between, that is drain and source. And again the length by electric field can be defined as voltage between drain and source by length. So finally it can be written as L square by mu VDS. Mu VDS. This is the tau. So we can write it as Q. So QC multiplied with mu VDS by L square. So this is the relation between IDS, but we need to substitute the QC value. So QC can be defined as electric field across the gate multiplied with epsilon naught free space permittivity, epsilon insulated materials permittivity, and mobility of the electron, already it is there, and VDS is there, VDS by multiplied with length into length of the transistor and width of the transistor by L square. So L square L cancel. The remaining is epsilon naught, epsilon INS, and mu by L. W by L is there, L multiplied with EZ, electric field across the gate. But what is saying, electric field across the gate for non-saturation region, electric field across the gate is equivalent to, that is VGS minus VT, at least half of the voltage between drain and source. So this is at non-saturation region. At non-saturation region, already it is VDS is there. So we need to write that. So it is at non-saturation region. This is the voltage for not going to saturation region. Minimum voltage for, that is not enough to go the transistor in saturation region. So substitute this one. So therefore, and he is assuming this part is equal to K, W by L multiplied with, what is the voltage, that is non-saturation region voltage is VGS minus VT by VDS by 2 multiplied with VDS. So this is at IDS at non-saturation region. If it is saturation, at saturation region, what is the voltage? The minimum voltage is VGS should be equal to at least VDS. Actually it should be greater, but what is saying, at least equal, so then only it will goes to saturation region. So substitute this one. So this is till this part, this is in non-saturation region. So substitute that one, K into W by L, VGS minus VT, minus VT minus VDS, VGS minus VT. VGS can be defined as, that is VGS should be equal to VDS. So therefore this is VDS minus VT minus VDS by 2. So this in saturation region VGS minus VT should be equal to VDS, should be equal to VGS. So then only it will goes to saturation region. This should be condition, first condition, and this is second condition. So we can write it as this one. Here we can say this VGS minus VT can be written as VDS minus VDS by 2 multiplied with VDS. So substitute this W by L, VDS into VDS square by 2, VDS square by 2 minus VDS into VDS into VDS square, VDS into VDS square by 2. So therefore we can write it as K into W by L, VDS square minus VDS square by 2 equal to VDS by 2. So this is at saturation region IDS for saturation region. So like this we need to find the VDS IDS relationship. Thank you.